I want to start by saying what an honor it is. I think I said this last night as well. What an honor it is for the Baker Institute to co-sponsor this conference and the dinner last night with the Academy of Medicine, Science, and Engineering of Texas, which we call TAMIST or TAMIST, depending on how you feel about it. The Texas Academy, I think you know, has done extraordinary work already in its young history to promote research in science, engineering, technology in the state of Texas. And Senator Hutchinson, of course, is the single most important person in making that happen. We were privileged to have the senator with us last night to share her views, and we'll show a video that she's prepared for us soon today. Those of you who were able to hear Dr. Letterman's remarks last night, I know came away with some new ideas, new perspective, a few new jokes, and I think and hope a renewed enthusiasm and maybe optimism that we can actually do something to help our teachers and help our schools in the K-12 arena in this country, and certainly in Texas. Maybe even got a different twist on physics, at least I hope so. You may have missed that, but he slipped in a little physics. I want to say a little about the Baker Institute, which is where we are today. This is the home of the Baker Institute and many of our academic departments as well. The Institute is nearly 15 years old. It was founded in 1993 to, quote, bridge the gap between theory and practice of public policy. So we're about action here. There are many distinguished policy institutions around the country and a long history of policy scholarship in the United States, and some of it is excellent. What makes the Baker Institute special, perhaps, is the emphasis on policy action, trying to focus on policy issues that are immediate and where it's possible to get something done. The Baker Institute is also one of the few think tanks in the country with a strong emphasis on science and technology. And given that science affects almost everybody, every aspect of everybody's lives, it's a sad statement that policy usually lags very far behind scientific knowledge. And we want to change that. Now, the Science and Technology Program, which I helped direct with Dr. Kirsten Matthews, who many of you will have met, who is the program manager, deals directly with issues such as science and math education, the subject of our conference. But the program in general looks to two different kinds of policies. Policies that directly impact scientific research, for example, research funding, the money, and the regulation of research, but also policies where science and technology can offer solutions to society's problems. And so here are a few examples of the things we've done at the Baker Institute with the Science Technology Program. We've hosted a successful conference series titled Stem Cells, Saving Lives, or Crossing Lines, which has presented the scientific, medical, ethical, and policy issues related to human embryonic stem cells. We've appreciated the help of our co-sponsors of those events, Baylor, MD Anderson, UT Health Science Center, UTMB, and the British Consulate. And we're going to hold a different kind of conference on February the 9th, whose focus is obvious in its title, I think, Beyond the Science, the Economics and Politics of Climate Change. So I think just from those two, you can see we're trying to focus on policy areas where that are important, where there's immediate discussion, and where maybe we can have some impact. And each year, as a part of something we call the Civic Science Lecture, we host a special lecture and bring a visitor from anywhere around the country. And this year, Dr. Shirley Ann Jackson, president of Rensselaer Polytech Institute and former chairman of the Nuclear Regulatory Commission, and a great African-American leader and great scientist. Dr. Jackson will be visiting us on November the 13th, and she'll present a talk with the title From Uncertainty to Opportunity, Creating a Comprehensive Energy Roadmap and the Human Capital to Make It Happen. It's a great talk. I hope you will be able to come. In addition to these examples, we collaborate with the other Baker Institute programs. For example, the Energy Studies Program, coordinated by Amy Myers-Jaffe, the Health Policy and Economics Program, which is run by Vivian Ho, the Baker Institute Chair in Economics, Space Policy Program run by George Abbey, who many of you know, the former director of the Johnson Space Center, who knows everybody and everything that has anything to do with space, and the Technology Society and Public Policy program run by Chris Bronk, Fellow of Computer and Information Technology. Baker Institute is also well known for its programs on other domestic and foreign policy issues. The Conflict Resolution Program, run by Baker Institute Director Edward Jerigian, former ambassador to Syria and to Israel in 2 different administrations, and of course, former Secretary of State and namesake for this institute, James Baker. The Transnational China Project, which is run by Baker Institute fellow Steve Lewis, and the Latin America Initiative coordinated by Erica de la Garza. So lots going on. We couple where we think we can be helpful, and we stay out of the way where maybe we are not needed. Now, today's conference, we're focusing on K-12 education for a couple of reasons that are entirely obvious to this audience. It's during these critical years that we can encourage, we have an opportunity to excite and encourage future scientists, engineers, physicians, and other technical professionals. But perhaps more importantly, K-12 is a time when all the people who do not become scientists and engineers, which means most of the people in the country, obtain their knowledge of science and the natural world. For many, it's the last formal schooling they will have in these subjects. K-12 can also be a time to reach parents. I remember well working with my kids and grandkids, studying chemistry, physics, even Latin. And some of the things that I worked with them on were things I'd forgotten. Other things I never knew. I mean, science moves fast, especially science moves fast. And it's very hard for the parents to catch up, but the point is they learn in the process, and I learned the hard way, I can tell you for sure, especially with Latin. By co-sponsoring this conference, the Texas Academy, I really want to emphasize this point, the Texas Academy is sending a very important message to all of us who are technical professionals, including University and Medical School faculty and researchers in science, engineering, and medicine, that we share with the K-12 teachers and the administrators the responsibility to make sure our students in Texas graduate with the proper scientific knowledge and tools that will enable them to be successful in any field they pursue in their future. This conference will also focus on recommendations proposed in the landmark National Academy report, Rising Above the Gathering Storm, which has had such an enormous impact across the nation. One of the points emphasized in the Gathering Storm report is the importance of providing teachers with a quality education and training, especially in the fields they will be teaching, as well as continuing teacher professional development. We'll be highlighting this topic in our conference. As I said last night, it's fitting that the conference be held on the Rice campus. It may not be widely known that Rice has been deeply engaged in K-12 education for 20 years or so, especially with a focus on content, knowledge, and professional development. Our Center for Education, chaired by Linda McNeil, in cooperation with the Houston Independent School District, is establishing an elementary school model science lab program at Sanchez Elementary. This program, directed by Rice Center's Dr. Wallace Dominy, will provide over 100 teachers a year from across the district with the tools, training, and ongoing support to transform their classrooms throughout the year and spread good practices to hundreds of more teachers. The elementary school program builds on the center's long successful partnership with HISD with middle and high school teachers. The resulting impact of student success with the TAKS test is apparent, but I think more importantly, the change in teachers' attitudes about science and scientific progress, the way teachers are able to communicate that enthusiasm back to their students, and actually a renewal of just the enjoyment of teaching, which sometimes gets pushed aside by all of the other constraints and pressures on this very important job. This really is, of course, where the value lies. So we have to continue more of what works. Now, our Rice School Math Project recently celebrated its 20th year anniversary and worked closely with the schools to improve mathematics teaching at all levels in the K-12 spectrum. Through a grant from the NSF, National Science Foundation, one of my favorite agencies, Dr. Ann Papakonstanou, who's director of the Rice School Math Project, is creating master teachers who are in turn a great influence over their peers. And our Rice Space Institute, directed by Pat Rife, has been producing curricular materials in astronomy, space and earth science for many years in partnership with the Houston Museum of Natural Science, where we were pleased to be last night. The Gathering Storm Report recommends more advanced placement in international baccalaureate programs, teacher training and summer institutes. And Rice has been working with the advanced placement community for 13 years and now implements one of the largest AP summer institutes in the country. This past year, we trained over 2,300 teachers from over 300 school districts in this country and overseas. We're also pleased to have the distinction of being the only university in the country that offers both AP and international baccalaureate teacher training. Many of the Rice research centers, institutes, academic departments bring teachers and students into the labs, engage them in cutting-edge research, and allow them to experience firsthand the excitement of discovery of scientific knowledge. And they carry that experience, that enthusiasm, that excitement back into the classrooms. We're very proud that a former student, Hafid Aziz, was named Houston's Independent School District's 2007 Secondary Teacher of the Year, and he's being honored in part for what he learned in Rice's Biotechnology and World Health course and implementing that knowledge in his class at Pin Oak Middle School. Several other faculty members in our university and other universities in Texas are engaged in working with big and small projects in improving K-12 education, and you'll hear about many more of those efforts in the presentations. And there are countless others, some of which we may not even know here today. As the world changes more rapidly than many of us would like, I think, our schools and teachers have to operate in that environment of changing needs and opportunities, and we need to do whatever we can to help. Dr. Leon Letterman gave us much to reflect on last night, and one thing he said was that we've known what needs to be done for a long time. We just haven't been able to do it. So I'm hopeful that we'll identify ways to do better in the future, at least in Texas. But wouldn't it be great if Texas could be the K-12 educational model for California, New York, sort of all those other places? I started to say Illinois, but I thought it might be offensive to Leon. So before I hand over the podium, I want to recognize the sponsors of this event. Again, Dow Chemical Company Foundation and the Greater Texas Foundation. None of this would have been possible without their support. I also want to specifically recognize the organizers of today's event, including Bill Brinkley, who will follow me on the podium, and Marianne Rankin, who you will see later in the meeting, who are co-chairs of the Education Committee. The TAMA staff, Gail McGee and Beth Henderson, and the Baker Institute staff, Kirsten Matthews, Sonna Fulbright, Melissa Llewellyn, Whitney Smith, and our interns, without whom we couldn't function, Jenny Kingsley, Sarah Tambra, and Emery Ellis. And of course, Siva Kumari, who you'll hear from later, was enormously helpful. So for all of those, please join me in offering applause. Now, next on the agenda is Senator Kay Bailey Hutchinson. Senator Hutchinson was unable to attend today, but wanted to say a few words to the audience. As many of you know, the senator is the first woman to represent Texas in the U.S. Senate, is a strong supporter of science in her role on the Committee on Commerce, Science, and Transportation. In 2004, Senator Hutchinson, along with Dr. Michael Brown and the late Richard Smalley, initiated the efforts to launch the Texas Academy, and she now serves as chairman for the Academy. So let's see, do we have the video ready? Do I do anything or just...
Hello, I'm Senator Kay Bailey Hutchison. I'm glad to be part of your conference. When I first envisioned the TAMIST organization several years ago, my focus was on increasing federal research funding in our state. Our efforts in this area have been very successful. Texas has moved to third in the nation for federal research funding in our institutions of higher education, and we're still growing. However, there is another pressing challenge I have asked TAMIST to address. Rising powers like China and India are threatening America's economic leadership, and we must refocus our efforts to meet that threat head-on. The recent National Academies report, Rising Above the Gathering Storm, illustrated my concerns about how precarious our economic position is. The United States graduates about 70,000 engineers annually, yet more than half come from overseas. India matriculates about 250,000 engineers, and China has an even greater number. If this trend continues, within a few years, 90% of all scientists and engineers in the world will live in Asia. We are starting to see the consequences of our neglect, as fewer innovators result in fewer innovations. In the 1990s, U.S. patent applications grew at an annual rate of 10%. Since 2001, the growth rate has slowed to less than 3%. By not replenishing America's well of innovations, we are seeing a fundamental and detrimental shift in the global economy. In particular, our trade balance in high-tech products has turned upside down. China has passed us as the world's largest exporter of information technology products, while we have become a net importer of those products. In a very real sense, the foundation of our economic prosperity is cracking. Norman Augustine, the former CEO of Lockheed Martin, who chaired the Gathering Storm panel, summed up the problem when he wrote, "In the 5 decades since I began working in the aerospace industry, I have never seen American business and academic leaders as concerned about this nation's future prosperity as they are today." As a state and nation, we must take immediate action. This year, I joined with many of my Senate colleagues to pass the America Competes Act. This bipartisan bill increases research, education, and innovation to strengthen America's long-term economic competitiveness. As a body of nationally recognized scholars, TAMIST can play a leading role in addressing this challenge. Today's forum on STEM education is an excellent start. The data exchanged this weekend will help us better understand how to recruit and retain more teachers in high-need fields. Your work will help us ensure Texas' continued leadership in these fields. I look forward to reading your conclusions and aiding your efforts in any way I can. I thank the TAMIST leadership and the Baker Institute for your work to organize this vital dialogue. Working together, I know we can find solutions to maintain our creative leadership.
Thank you, Senator. It's now my great pleasure to introduce good friend and colleague, Dr. Bill Brinkley, the Texas Academy Education Committee co-chair. In his normal life, day job, he's Dean of the Graduate School of Biomedical Sciences and Senior Vice President for Graduate Science at Baylor College of Medicine. Bill has been a great contributor to many of the science and technology policy events here and has worked tirelessly over the past years to help improve science education, promote biomedical research, and encourage enlightened stem cell policies in the state of Texas and around the nation. Therefore, it was not a surprise that he was chosen to chair the TAMIST Education Committee and help develop this important project on Texas K-12 science math education for the Academy. So please welcome a good friend of education, science in Texas, Bill Brinkley.
Thank you, Dr. Lane, and thank you for giving us the opportunity to have this venue, the Baker Institute, this prestige, allow us to bring to you this major problem and conundrum that faces us today on science, K-12 science and engineering and math education. And I want to thank all of you for participating. As I look at the speakers and the committees and the various session leaders this morning across the state, I can't help but believe that if we can't find the solution to this problem with this group of experts in this room, we are missing a wonderful opportunity, and I don't know that we'll ever find the solution. So I'm hoping that today is the beginning of a strategy, as Neil said, that will enable us to take the leadership in fixing this problem. What is the problem, and how can we fix it? We've asked our speakers and our panels to not give us their opinions, stay away from anecdotal presentations, but give us data. And we're expecting the audience to participate because, as I'll say in a moment, each of you have cards in your seat, and there will be an opportunity for you to ask questions during the presentations and raise your cards, and we'll have students come by and pick them up, and the session moderators will try to answer as many of those as we can. So we're grateful for all of you being here and giving up your good golf and good tennis or whatever makes you happy, as Marvin Zinner used to say, on this morning as we begin to take this enormous problem on. This is a historical occasion. So you've heard already what TAMIST is, the acronym and what it means, the Academy. And let me just go and recognize a couple of leaders that are here this morning, a few leaders, more than a couple. Of course, Dan Foster, the president, is here and spoke to us last evening. Dr. Donald Paul, a past president, is here on the front. Dr. Tinsley Oden, the vice president, our next president here from the University of Texas at Austin, as well as Dr. Paul. And Dr. Ken Arnold, I believe, is here from Houston. So we have our leaders. There are other members of the board that are here that I'm going to mention in the Education Steering Committee. Now, TAMIST took this project on as its first major project since its origin, and that is to try to do something constructive and make Texas a leader in this issue of K-12 science education. And they appointed an Education Steering Committee, and I'm very happy to mention the names of those folks who worked very hard. Of course, my co-worker, Dr. Marian Rankin, is already well known as a leader in K-12 science education, and we'll be hearing from her later today. Mr. Ernie Cockrell, a leader, the Cockrell Interest is here, who was on the committee. Mr. Peter O'Donnell, as you all know, the O'Donnell Foundation was on the committee. And Dr. Neil Lane, Dr. Betty Sue Masters was here, and she was from the University of Texas, San Antonio, a very important member of the board as well. Joe Newton, Dr. Joseph Newton, Dean of the College of Sciences at Texas A&M University, is also on the committee. And Mr. Kurt Swager, who is a VP for Business Development in Dow Chemical, has been a real inspiration as well as a member of the committee, trying to get us to think, I think, like we academicians don't normally think about, and that is, what's the product we're trying to sell here, and how, and what's the audience, and how do we sell it? And then, of course, Dr. Richard Tapia is a member of the Academy of Engineering and is at Rice University, and I'll introduce him. He's also a board member of TAMIST. So that's our hardworking group, along with the staff. And the charge for the day, as you know, you heard from the senator, is we'll ultimately report to her a white paper that hopefully will identify and provide data on the specific issue of K-12 STEM education, what we're doing wrong, and how we can correct that. So that's our purpose. We want to try to fulfill that, and we want to have a successful program. I want to begin this morning, though, with the first recognition of the real heroes in this whole project, and that's the teachers, the dedicated teachers. And so we all know that that's as the core solution, one of the core solutions to this problem has to do with attracting and improving the benefits and recognizing the importance of our teachers We've asked Mrs. Dixie Ross, and the advanced placement calculus teacher at Pflugerville High School, to begin our day with a teacher's perspective. And Ms. Ross is an AP consultant and test reader responsible for training hundreds of teachers throughout the nation on her innovative and effective approach to teaching calculus. She also spearheads the TEA efforts to produce math vertical teams guides for the state of Texas. So at this time, I'd like to ask Ms. Dixie Ross to come and give us a presentation.
Good morning. My name is Dixie Ross, and I teach at Pflugerville High School, which is outside of Austin, Texas. If you've ever happened to come across an NBC show on Thursday nights, Friday Night Lights, strange that they put it on Thursday nights, that's my school. That's my school. When you see the football games, that's our team. The Dillon Panthers are really the Pflugerville Panthers. And when you see the band, it's our band. When you see the drill team, it's our drill team. When you see the cheerleaders, those are our cheerleaders. When you see the kids that are drinking and having sex, those are the actors. I've been trying to convince the producers that they really need to have an episode that revolves all around a calculus teacher. So far, they haven't taken me up on that offer. Apparently, there's a lot of people who still think that Texas high school football is more interesting than Texas high school calculus. So I'm hoping that that's one of the problems we'll address this weekend. Anyways, I'm here today to offer greetings and gratitude. I'm thankful, like all of the educators that are here today, to have been included in this very important discussion regarding the future of mathematics and science education in Texas. It's amazing to me how often people set about to solve problems in education without consulting those they expect to implement the solutions they design. Perhaps that's partially why implementation has failed in the past. We're thankful to TAMIST, the Baker Institute, Rice University, Dow Chemical, and the Greater Texas Foundation for having us be a part of this event. As I look out at all of you, I see a lot of friends and fellow educators who have set a high standard in terms of dedication to their craft and creativity in the art of teaching. I'm privileged just to know a lot of these teachers and thankful for the opportunities I've had to learn from them in order to be more effective in my own classroom practice. We have so many distinguished practitioners today that it would be impossible to single everyone out for individual recognition this morning. They're listed in the program along with their achievements and their teaching philosophy. So I would ask the teachers now to stand and be recognized as a group. Unfortunately, there were two groups that were not included in the program. The Science Education Leadership Fellows, teams of elementary teachers and Baylor College of Medicine scientists funded by the Howard Medical Institute, and the National Science Foundation GK-12 partners, teams of high school biology teachers and Baylor College of Medicine grad students. So I'll ask those people to stand and be recognized as well. I also want to take this chance to send out congratulations to Austin ISD math teacher Cindy Carroll, who earlier this week received the Milken Educator Award. Cindy, you've had quite a week. I think she's treating us all for cocktails later today, right, Cindy? We have with us today Presidential Award finalists and winners, recipients of the prestigious Siemens Award, teachers whose programs have been recognized for excellence in the College Board's annual report to the nation as being the very best AP programs in the entire country. What I want everyone to know is that we have wonderful things happening in Texas. Great work is being done to prepare the next generation of mathematicians, science, engineers, technologists, and teachers. What these folks are doing should serve as a model for the rest of the nation. Amidst those gathering storm clouds that we have heard so much about, there are classrooms where the sun is shining brightly. The problem that we are here to confront today is largely one of scalability. What we currently have is what Kathy Seeley has so aptly described as pockets of wonderfulness. How can we make sure that the wonderful and amazing things that are happening in these science and math classrooms are actually happening in every classroom across this great state? Doesn't every child in Texas deserve to have a teacher with the passion of Wanda Savage, with the depth of knowledge of someone like Robert Dennison? This is how we will ultimately measure our success. Does every child in Texas have the teacher you want your own child to have? I recently had the experience of serving on a committee. I often get dragged into serving on various committees. But this was actually a pretty fun and interesting one. Our charge was to select a professor for the Massey Award, an award given at UT Austin for a teacher of teachers. And I have to tell you that I came onto this committee with my own particular bias. I value the classroom above all else. And I know a lot of the teachers here feel the same way. If this event had been held on a school day, a lot of them would have been reluctant to come because they hate being out of the classroom. They'd rather give up their golf and tennis, I suppose, on the Saturday. Or, no, I guess it was the grading of papers. Sorry. Anyways, I came into this committee room looking primarily at evaluations of the candidate's classroom performance. What I didn't value at all was publication. I think my exact thoughts were something along the line of publication, schmublication, nobody reads that junk anyways. Luckily, this was one of the rare occasions when I actually kept my thoughts to myself, because the man who's sitting next to me on the committee, a retired NASA engineer, made me see things a lot differently. He said, without publication, they won't have an impact beyond their own classroom. And it was like one of those little cartoon light bulbs went on over my head. It's going to be really hard for us to replicate all of this wonderfulness that we have going on when we've not documented or described the things that we're doing. And this is my challenge to my fellow teachers today. We need to find ways to create impact beyond our own classrooms, beyond our own school buildings, and beyond those few kids that are lucky enough to be in our classes. We need to participate in events like this and work to help implement systemic change. This is also my challenge to the non-educators here today, who, like the NASA engineer, bring a different perspective to this discussion. You need to find ways to tap into this tremendous wealth of talent and experience to give teachers a chance to influence policy and practice across Texas. This is truly a challenge for all of us, but one that we must rise to meet. Last night, Dr. Letterman referred to events that served as a catalyst to scientific advancement. And I think there's probably one event that most of us remember really, really well. In his 1960 inaugural address, President Kennedy put forth a challenge. He got up there and he said, by the end of this decade, we're going to put a man on the moon. And we're going to do it with technologies we haven't even invented yet. Now, how audacious is that? It almost sounds crazy. Nobody imagined that that would actually be possible. And yet, less than a decade later, I was here in Houston, Texas. It was the first time I got to stay up all night long. And what were the very first words? Houston. He was talking to us. He was talking to us here in Texas because Texas had been the ones to rise up to help meet this challenge. And then later, in Apollo 13, and a lot of people remember it best from the movie. What did they say? What is the classic line? Houston, we have a problem, right? They're looking to Texas to find the solution to that problem. And everybody remembers the scene in the movie. Finally, there's a movie, and it's not the cops, and it's not the cowboys, but it's the engineers. And they come into the room, and they dump a bunch of stuff on the table. And they said, look, this is what we have to work with, and we've got to solve this problem. And that's what I think this conference is. We're going to dump all this stuff on the table, and we're going to try to come up with a solution. I have a lot of pride in Texas. I think a lot of people do. And we have risen up to meet that challenge over and over again. Texas has been the one that they've turned to. Rising above the gathering storm, Texas can certainly rise to meet this challenge.
Dixie, wow, that's the way to get started. Thank you so much for that inspiring keynote. And we have another keynote speaker that we're very honored to present to you this morning to give the second address. Dr. Richard Tapia, who is, I mentioned earlier, is a member of the board of TAMIST and also a member of the Education Committee. He's a university professor and Maxwell Oshman Professor in Engineering at the Department of Computational and Applied Mathematics at Rice University. He's a director of the Center of Excellence and Equity in Education, powerful spokesman for the underrepresented. TAMIS board member and education committee member, national advocate for improving math and science in education. Dr. Tapia's talk is entitled Math and Science Education for All, a challenge to the greatness of Texas. Dr. Tapia.
I thank TAMIS for actually initiating this activity, and I thank Bill Brinkley and Marianne Rankin for their excellent leadership in our subcommittee. Okay? So math and science education for all, a challenge to the greatness of Texas. Okay? Now I have to find the buttons. Okay? Here. Okay? A richness of Texas, our current demographics. African American, 12%. Asian American, 4%. Hispanic American, 37%, and growing very, very fast, the fastest growing Hispanic population in the country. Here's an awareness that I say. The Hispanic population nationwide is growing at essentially a linear rate, if you look at the data. The Hispanic population in California and Texas is growing at an exponential rate. What does that mean to us? The inevitable browning of California and Texas first, and then the browning of the country. Okay, let's go. Here's an education axiom. We should not be able to predict quality of education received by race or ethnicity. Unfortunately, this is the case now. This is the beginning of a class system, particularly bad when it follows racial lines. Race and ethnicity should not dictate educational destiny. We have problems ahead. Rising above the gathering storm. How do we maintain the U.S. leading edge in innovation? An incredibly important question. How do we maintain our scientific and technological workforce? Equally important. Two solutions. The old solution was importation. We import talent from overseas, but the old solution is not working much anymore. Talent is coming here and going back home, or not coming here. The hard fix, which we've always known, is to bring U.S. minorities into STEM in much larger numbers. Underrepresented minorities are a big part of the problem, hence they must be involved in the solution. Can Texas lead the way in creating educational parity in increasingly diverse United States? Those are the questions we're asking, and I commend us on asking the question and trying to go forward on these issues. Here's some sobering statistics. Texas Tier 1 universities, mathematics department faculties. Okay, so if we look at African American, how many African Americans do we have in the faculties of Rice University, University of Houston, Texas A&M, University of Texas? The number is 0. That's not rounded. It's 0. Okay. Hispanic native born, Rice 0, University of Houston 1. He was my student. University of Texas 2. Texas A&M. I was just talking to Joe Newton this morning, and we decided that the 0 should be replaced by 1. Okay? We had Hispanics, several foreign-born, but we decided there was one that is actually domestic-born. Now you realize going from 0 to 1 is infinite improvement. Okay? Okay? Now what's the danger of 1? The danger of 1 is say, we have ours, now you get yours. Okay? 1's not enough. Sobering statistics. Sure, we excite, we say how great we're doing. Yet, look at the representation on the faculty of Tier 1 schools in terms of underrepresented minorities in science and engineering. It is sad. I want to share 3 stories with you. The first one, Carl Hayden High School. Okay, look at the picture of these things. Let's look at these students. Now, here's what happened with these students. Most of you know the story. If you don't, you should, Google Carl Hayden High School and read this. It'll bring tears to your eyes if you have any tears left. I'm out of them, okay? But I tried, okay? I tried to cry. A team of Mexican-American kids, children of undocumented workers, created a Rube Goldberg-type robot that beat the MIT team's slick entry in national competition. They won on innovation. What was the innovation? Okay, they decided that they would put the guidance system in an attaché case and attach it to the robot. So it went into the water. Other places had a guidance cable, and they would keep the guidance system in dry property. Now, the attaché case started to leak. And one of them said, I saw a commercial on TV for absorbent tampons, okay? Go get one. The other one said, no, I'm not going to go get it. You go get it, okay? So they drew straws, and one of them went to the drugstore and closed his eyes and said, can we have the most absorbent tampon, okay? They took it back, they stuck it in the corner of the attaché case, it stopped the leak, they won the award, and they won national championship, okay, over MIT, okay? Non-standard innovation, huh, okay? By any conventional academic standards of measurement, these students would show little promise. They had poor grades, but they were smart, and they were innovative. Just the kind of kids Rags tells us we need in order to maintain U.S. competitiveness. We need them. Lessons from the Carl Hayden story. Lesson 1, underrepresented minority students can be very innovative. Lesson 2, conventional ways of judging ability, grades, and standardized testing do not tell the complete story. They put many minority students at a disadvantage. We know that. Lesson 3, for underrepresented minorities students, we have a problem, a demand problem, not a supply problem. It's not that don't have the wonderful teachers that we've seen today. It's not that we don't have the curriculum. They don't want it. Go to the corner over here in the 3rd Ward and tell all these students who are hanging out there, let's say on Friday night or Saturday night, how would you like to be a scientist? How would you like to be a mathematician? And they would say, why? I'm perfectly normal. There's nothing wrong with me, okay? Why would I do such a thing, okay? Demand problem, okay, not supply. Story 2, the HISD 5th grade KISS. So if you look at this data, the top 2 lines, the green is white, the one below that is Asian, blue is Hispanic, and red at the bottom is African American. Now, this is the 5th grade KISS. Notice that from the 3rd grade, and this is basically the math TAWS, but it doesn't matter. It would be the same thing on other things. Everything goes well up to the 5th grade. We're closing the gap. When George Bush wanted to be known as an education president, he gave data from HISD for the 4th grade. We closed the gap. Had you given 8th grade data, it would have been a different story. Okay? What happens after the 5th grade? We go crash. We go crash. So we're closing. So it isn't that we start behind and we just increase in a monotonic fashion. We start to increase and then we go crash. So maybe we should close down middle schools. Maybe we should never have them. I don't know. Okay? Look at the dropout rate. Now, this is a conservative estimate. This is an estimate that no one can argue with. 10% dropout, Asian, white, 15, African American, 30, Hispanic, 40, and probably bigger than that. What are the lessons that we can see from the 5th grade KISS? Lesson 1, ability is not the only factor that accounts for performance. Again, it's a demand problem, and culture influences demand. How do we promote demand? It is not the same thing as changing culture. We don't want to do that. There's a lot we still don't understand, okay? Culture is an issue. Can't change culture, but we have to share. Story 3, Texas top 10% rule. All right, so you all know about this. The Texas top 10% rule, House Bill 588, 1997, was a very bold experiment to counter the loss of affirmative action with the Hopwood decision. Standardized scores were to be ignored in favor of class rank in admissions. Now, our legislators came up with it. No self-respecting educator would have initiated or endorsed the Texas top 10% rule. And that includes me. It's not going to work. You're going to get students who are not prepared. It's not going to work. But it works. UT Austin undergraduate, underrepresented minority population, 28% in math, 28% engineering, 40% of the freshman class. Minority math representation is on par with other science and engineering disciplines. This is highly unusual. UT Austin has the highest underrepresented minority population in science and engineering and math of any Tier 1 school in the United States. You don't believe me? Look, UT Austin, 28%. UC Berkeley, 4%. See, California hasn't learned how to get around Proposition 209. They just sit there and say, oh my God, look what they've done to us. We were a little bit bolder. Now, granted, it wasn't the administrators, it wasn't the educators, and it wasn't the faculty that put in the top 10%. But we got there, okay? Okay, the Texas 10% rule works. Why? Although math departments are usually one of the most minority-unfriendly departments in any university, without a doubt, I can say that as a mathematician, UT's math and other faculty stepped up to the plate and instituted a lot of support programs. Most of the information that I've gotten here, I talked extensively with Ephraim Armendariz, the chair of the math department at UT. We had a lot of conversations about it. So they stepped up to the plate. Instead of, granted, these people came unprepared, but they prepared them to the level that retention among minorities at UT Austin in mathematics is as high, if not higher, than the average. Okay. It turned unfortunate circumstances into a positive outcome. Positive outcome from unfortunate circumstances. Why did the 10% rule work? Because high schools in Texas are de facto segregated. So 10% leads to black-brown parity in the freshman class. If they were integrated, maybe it wouldn't have worked at all. Good things from bad things. UT Austin and the Seven Dwarfs, okay? Non-uniform distribution. We have essentially a flagship UT and then other branches, okay? But everybody wants to go to UT Austin. Now, if I gave you California, arguably, UCLA, San Diego, Davis, Irvine could be arguably as good as Berkeley. But there's 7 or 8 schools. In our lack of wisdom, we built UT Austin and the Seven Dwarfs. And everybody wants to go see Snow White. Among the many lessons that we have learned from the UT story, there are things that we can do to boost student performance. Sink or swim is progressively more and more ineffective as an approach to our education. Faculty have to buy in. We hold K-12 teachers accountable. You teach what you get, and we hold you accountable. Not with university faculty. Oh, they weren't prepared. They can't make it. I'm sorry. Challenges that receive insufficient attention. The demand problem. We keep talking about educating them. Do they want it? Making minorities more education savvy. When I deal with minority students in high school, they don't know the ropes. They don't come with parents who went to have degrees and knew and understood these things. They don't understand that. Cultural differences. Asians, blacks, Mexican Americans, Jewish kids, and Anglos are culturally very different. It's not a matter of changing the culture, but we need to learn from each other and share those things that succeed. The new reality, undergraduate degree is now basic education. It's like K-12 was at one time. K-12 and universities must develop a better interface. Counseling is as critical as instruction in today's world. K-12 must understand how to guide the best students to the best schools. There are many big science literacy issues before the public. Texas is deeply involved in all of them. These are science issues. TAMIS has to be involved. The environment, global warming, air pollution, politics and religion, the teaching of creationism. These are scientific issues that we must face. TAMIS needs to address them. These conferences like this need to go and understand them. Because the cumulative nature of science and mathematics, STEM education has to be done right all the way. We can't just pick it up at the end. If we do not prepare students well in K-12, you can't make it up at the college level. And that's what we're trying to do. My warning, the rate at which the minority population is growing outpaces the rate at which we are improving our effectiveness in educating this segment of the population. That's the strong statement. The minority population is growing at a faster rate than the rate that we're improving our effectiveness in educating this segment of the population. That's a challenge for Texas if we're going to lead the nation. Education is a cultural issue. It is complex. Progress is slow. Minority issues vary from group to group. You can't have one solution for all. I have an op-ed piece in the Chronicle of Higher Education is entitled, "True Diversity Does Not Come From Abroad." And if you Google Chronicle of Higher Education, then click on opinions and then do a search on Tapia or Richard Tapia, you'll see this op-ed piece that you might want to look at. It's a case of nurture, not nature. One final point. Educators are like medical personnel when it comes to immigration. We do our job to teach, to heal, without reference to legal and political issues. I'm going to end this with a quote that I borrowed from our president, David Lee Brown. It is discouraging that some of our policymakers fail to understand that our future depends in many ways on creating opportunities for immigrant children. Whether these children are legal or illegal will turn out to be irrelevant 20 years from now, except to the extent that they are deprived of the chance to contribute to our society. David Lee Brown, President of Rice University. Thank you.
Thank you, Dr. Tapia. Who said mathematicians couldn't preach? That was beautiful. And a great way to start with both of our keynote speakers this morning now have set the stage. And now we get into the presentations of our panels. And the first panel this morning is a Texas snapshot, a look at the data. You start off by where are we? We need data, and we're going to see that. By the way, after each panel discussion, there will be an opportunity for the panel to answer questions from the audience. Excuse me. Question cards have been placed on each seat, and although the panel discussion is it's difficult to get questions in at the end because we have a very tight schedule, we will get those questions passed down, and the panel moderator will try to answer as many as possible. In your folders, you'll also find a feedback form. The purpose of this event is to begin the process of developing recommendations to improve science and math in Texas. We need you to put down your thoughts. This is our database, folks, and you're going to be providing it. You're the ones that are capable of doing it, and we need your thoughts. So now I'd like to introduce one of my heroes, Dr. Bill Thompson, who is a professor of allied health science and family community medicine at Baylor College of Medicine. He's the director of Center of Education Outreach and the deputy director of the Center for Collaborative and Interactive Technologies. I have to tell you before I step down that Bill and I have been colleagues at Baylor for many, many years. And he is the one that made me and many of my colleagues realize that we have to reach out to the public schools, and we have to have outreach programs so that professors and scientists can go to those schools and we can bring their teachers and students to Baylor and to other schools to share the knowledge that we have. And this is vital, and he's been one of the pioneers. Bill.
Thank you, Bill. Good morning. Bill Brinkley is so kind in his comments. He opened his laboratories to high school students and to high school teachers almost 35 years ago, and it was prior to that point that did not happen. Bob Alford's in the audience, and he and the leadership of Baylor College of Medicine established the nation's first high school for health professions in 1972. And from there, the programs have grown and evolved into now over 20 active programs that are making a difference not only within Texas, but nationally and internationally. So I'm just proud to be part of the team that reaches out to our communities. So over the 30 years, we've learned a lot. And we keep on asking questions, and it's and one of my favorite metaphors when I have an opportunity of speaking with people is the Red Queen effect, the Red Queen principle. If you remember from Lewis Carroll's Through the Looking Glass, the Red Queen is always running, but she never gets there because the landscape moves along with her. And in biology, the corollary is if a system doesn't evolve, it doesn't survive. So thus, if we do nothing, we fall behind. And so if we run real fast, we stay where we are. And I think we've run real fast, and we're staying where we are. But in order to move forward, we have to run faster and maybe run better as a species. The Texas Snapshot, a look at the data, is going to be a data ride. I have seen the presentations, and I want you, the group, to know that I reorganized your slides just a few minutes ago with the guys in the back. And so you'll be a little excited as you look up there, and so it'll be stimulating for you. But But hopefully we can provide the context for the learning that will occur this morning. And we have three panelists, all who have greatly contributed to our understanding of the systems. And I'll introduce each of them separately, but just so you know who they are, Dr. Steve Murdoch is probably one of the best known and respected demographers in the nation. He is joining us today. Dr. Dar Winnig, who has spent his entire life arguing for accountability and evidence-based education in our nation's schools. And Dr. Tim Scott, who is rapidly emerging as a leader. He's a younger professional, dean at Texas A&M University. And we're happy that he's here because the clock is working against Steve, Bill, and Dar very rapidly. And Tim, you can give this talk 30 years from now and use the same metaphor that I did, but hopefully we'll run faster. Our first speaker is Dr. Steve Murdoch, a man who lives by the numbers. He's currently here at Rice University awaiting his confirmation as the director of the United States Senate. Texas Monthly has described Steve as the prophet of data, and its list of most popular Texas who are data types of popularity people. And he is a state's official demographer. He's a distinguished professor at several universities, and he is an expert at teasing out data from populations that deal with elementary school, little league mothers to people who are making decisions about our economy and the direction we're going. Two things stand out to me about you, Steve. One is that you came to Texas on the day Elvis died. That would be something, a hallmark of your career. And the second is that Bill Hobby, those of you who know Mr. Hobby, who is here at Rice University, said that no one has done more about generating an understanding of data for the state of Texas than Dr. Steve Murdoch. Steve.
Well, thank you. It's a pleasure to be here. It's a little bit intimidating to be in front of this august body, but if I weren't a demographer, I would be more intimidated, and that is because, as most of you know, we in demography, we know we have a divine calling. Now, we know that's true because there's a book of Numbers in the Bible, and it's all about censuses. Check it out. You'll see that we're correct. Well, what I want to talk about today, very briefly, are the three demographic changes that I argue are so important that if we fail to understand these, I don't care if you're in Texas or Illinois or Michigan or any place in the United States, they are so important that if you fail to understand them, you can use the old action plan to fail, because they are changing Texas and the nation in ways that are irreversible. We're going to talk about population growth, we're going to talk about the increase in the diversity, and we're going to talk a little bit about one of those things that I find increasingly difficult to talk about, the aging of the population. Let's talk about where we are in population growth. You know, if you look at this chart, I like to say that the most important part of this is on those two right-hand columns that show that in every period of time since Texas first allowed the U.S. to join it, we have grown more rapidly than the country as a whole. As you can see, in the decade of the 90s, by 23% compared to 13% in the country as a whole. And in this most recent data, and the most recent data we have is for July 1st of 2006. So from April 1st, 2000, the census date, to July 1st of 2006, we've increased about 12.7%, again, about twice as fast as the country as a whole. If you look at our growth in the 90s, 3.9 million people added to our population. To put that in perspective, that is roughly equivalent to having added in a single decade the number of people who in 1990 lived in the city of Houston, plus the city of Dallas, plus the city of San Antonio, plus the city of Corpus Christi. That 3.9 million was greater than the total population of 24 of the 50 states, and that 3.9 million meant that nearly 1 of every 8 persons added to the U.S. population was added in Texas. And what have we done this decade? Well, we've added another 2.7 million so far in the first 6.25 years. We are growing at a rate such that by the end of this decade, we will probably have added another 3.6 to 4 million new Texans. That will be about the same number, a smaller percentage increase perhaps, but still tremendous population growth. You can see in the 90s we were the 8th fastest growing in percentage terms. In this post-2000 period of time, we are the 7th fastest growing in percentage terms. And whether you look at the largest states in 2000 or you look at the largest states in 2006, you see that only Florida and Georgia and to some extent North Carolina are growing anywhere nearly as rapidly as we are. Some states have had relatively little growth. For example, New York has increased by only 1.7%. I like to say to that as proof positive that you cannot have good population growth if you have bad picante sauce. As important as the growth in numbers is the change and diversification of our population. If you look at Texas, you know, we're the second largest state, having bypassed New York in the first part of the 1990s, so only California is larger. But in 2000, we had the third largest Anglo or non-Hispanic white population, second largest African American, second largest Hispanic population, and fourth largest other. And by other, we mean primarily Asian, although it includes Native Americans and some others as well. When you look at our contributions, you can see we were the second largest contributor to the Anglo population, third to the African American population. And you know what's interesting, when you look, we're also second in terms of the Hispanic population, but notice that we were second in terms of the numerical increase in the Anglo population with 783,000 increase, but the increase in the Hispanic population was 2.3 million people. As a result of that, we became a state by 2004 that was less than half Anglo. We are now, as you see, about 48% Anglo, about 36 to 37%, as our previous speaker said, that is Hispanic, about 11 to 12% African American. And if you begin to see what's happened to us, you begin to see that our diversification is increasing. If you look at net population change in the 1980s, 2 of every 3 net additions were non-Anglo. 50% of the total net additions were Hispanic. 1990s, 8 of every 10 were non-Anglo. About 60% was Hispanic. And in the 2000 to 2005 data, you can see about 87% of the net additions to our population were non-Anglo. 68% basically was Hispanic. So the diversification is increasing. Well, let's talk about age for a few minutes, and that's a factor I find increasingly difficult to talk about. However, I do want you all to know that my hair is not naturally this color. Now, as several of my colleagues in here, use gray in to look more sophisticated. I think it's working very well, and not in terms of my sophistication. But let's look at age for just a few minutes because it is such a critical factor. 2 things are important. One is we in Texas, like the rest of the country, are in aggregate sense getting older. You can see this in this particular chart. You can see, for example, that, you know, in 1950 we were a population with a median age of about 28%, about 28 years rather. By 1980, 30 years later, you can see we basically went up 0.1% from 27.9 in 50 to 28 in 1980. Then from 1980 to 1990, we went up about 3 years from 1990 to 2000, about another year and a half. Well, what's going on? Well, it's the aging of that infamous group of people called the baby boomers. Those people born between 1946 and 1964, those of us in that group are about a quarter of the U.S. population, about a quarter of the Texas population. And as one of those baby boomers, I like to say, as we go, so goes the country. Now, we're an important group of people. Do not be shy, my baby boomer friends. The reason we're so important is that we have rippled everything we've gone through. Rippled the elementary and secondary schools, we rippled the colleges and universities. And if you don't think we're still rippling, look at this chart. I'll give you 3 guesses, none of which count, of which of those age groups up there has the front end of the baby boomers. Well, as you might guess, it's that 45 to 54-year-old age group. But a second thing about our age structure is even more important, and that is there's a clear relationship in Texas and across the country between non-Anglo status and youth status. I want you to take a look at this and see how that appears in Texas. This chart represents just 2 of our 4 racial and ethnic groups. The blue represents the Anglo population. The red represents the Hispanic population. This is the census count. We're not showing the rest of the population here, but if you look at the population 65 plus, what do you see? 73% is Anglo, about 17% is Hispanic, but go to the other end of the age spectrum, what do you see? About 40% Anglo, about 44% Hispanic, and when you put the other racial and ethnic groups in there, you mean you're talking about basically 60% of the total population being non-Anglo. And in fact, if you take the entire population in Texas in the 2000 census that was less than 18 years of age, 57% of that population was non-Anglo. Now, when I look at that chart head on like you do right now, like you are doing, when I go to the right, I see Texas past. When I go to the left, I see Texas future. Now, sometimes when I say that, people say, well, that's a little bit sensational thing to say. How can you say that? Well, I want to show you the next chart. And remember, the blue up here represents the Anglo population. The red represents the Hispanic population. What you're looking at here is 2000. This is 2040. This is 2000. This is 2040. So the changes we are seeing are very dramatic indeed. Well, what do we expect for the future? Now, this is one of those charts I like to say that only a demographer could love. but it shows our projections of the population. The three in the bottom are the only ones that have any chance of being correct. But the third one suggests that if nothing happens, if we continue to grow as we did in the 1990s, we would by 2040 in Texas have nearly 52 million people. We don't think it's going to be that great. We think it's going to be somewhere in the 40 to 45 range, but still dramatic growth. In fact, to give you an idea, those three bottom ones, which are the ones that we think have some possibility of being correct in that period of time, the slowest of those shows a 72% rate of growth over the next 40 years. The U.S. population as a whole, projected by the Census Bureau for 50 years, not 40 years, but 50 years, projects about a 48% increase, so we expect Texas to grow faster than the country as a whole. Second thing I want you to notice about there is under the scenario in which the Anglo population grows the most, it grows by less than 12% over the next 40 years under the highest growth scenario for Anglos. On the other hand, you can see under that same scenario, the African American population grows 71%, the Hispanic by over 350%, the other population by over nearly 570%. As a result of this, we do expect our state, which is already less than half Anglo, to become somewhere between 2025 and 2035 over 50% Hispanic, and that by 2040 we'll be somewhere between a quarter and a third Anglo, somewhere between 8 and 10% African American, somewhere between about 53 and 59% Hispanic, and somewhere between 6 and 9% will be members of other racial and ethnic groups, primarily Asian. In fact, of our net population growth during the next 40 years, the proportion of we expect to be due to the Anglo population is shown in blue. In terms of net change, 96% of the net additions to our population we expect to be non-Anglo. And we will have, by 2040, under some scenarios at least, about 1 of every 5 Texans, like 1 of every 5 Americans, will 65 years of age or older. Well, why should we care about these factors? Well, due to a variety of historical, discriminatory, and other factors, these demographic characteristics are tied to socioeconomic characteristics. They are tied to the resources that people have to buy goods and services in the private sector. They are tied to the resources that people have to pay taxes in the public sector. And if we change, as we, and by the way, many others demographers project us to change, we will as we change our population. In the absence of socioeconomic change, primarily as a result of education, we will, as we change our population, change the very economy of Texas. Now, why is that true, and what are some of these implications? Well, I'll show you just this one. I want you to just look at that green bar up there that shows that in 2000, still over 50% of adult Hispanics in Texas had less than a high school level of education. And where do we stand? Well, in 2000, we ranked 45th among all the states in terms of the percent of the adult population with a high school degree. By 2004, and for each of the last 2 years, we have ranked 50th among the 50 states in terms of the percent of our adult population with a high school degree. College degrees, 27th in 2000 and 35th in 2004. Well, what are some of the other implications of these demographic changes if we do not change the socioeconomic factors? Well, we would have a labor force that is less well educated in 2040 than it is today. And up here you can see that by 2000 shown in blue, 2040 shown in red. So any place where the red is taller than blue is where the growth is going to be. We would be a population that is poor, with the average Texas household being $6,500 poorer in 2000 constant dollars in 2040 than it was in 2000, and poor indeed, with the percentage of family households in poverty increasing by about 4%. Well, what do we propose, or what do we project specifically for education? Now, I want to show you, look at that red bar up there. When I first published these, I had a number of lawmakers come to me and say, Murdoch, you know, sometimes you've exaggerated things, but this time you've exaggerated beyond any reasonable level. Well, I want to tell you one thing. You know what? In all the projections I'm going to show you today, you take that highest projection, and we're actually running above that projection today. So we were projecting, you know, and I've got to say that sometimes I get, you know, I don't know what's wrong with our school teachers because they complain. And I don't know why, because all we want them to do is absorb another 3 million kids into Texas elementary and secondary schools. What is the big deal? Well, what we're going to see in terms of change is this is the demographics. And you can see that by 2040, 8 of every 10 kids in Texas public schools are going to be non-Anglo. If you look at our colleges and universities, projections also are running higher than these two, which are for community college and public universities. But what's going to happen? Well, community colleges are going to go from 55% Anglo down to about 26% Anglo. Public universities from about 62% Anglo down to about 32% Anglo. And what happens if we don't change anything? What we've done here is taking our projections for the school population and looked at their involvement by age, sex, and race, ethnicity as it existed in 2000, projected forward, said, how much growth would we have in each of these programs? Well, if they grew just at the per capita rate, that red line would be where all those bars stopped. But you can see what we expect to grow as a result of our demographic change if we do not reverse these, if we do not change them with education. I'll just have you look for a minute. Note that the shortest bar of all is the gifted and talented branch, or the gifted and talented program. Well, checked with my former colleague, Professor Newton. He told me this was absolutely true. But I want to say simply in summing up is this. The changes we expect in the demographic population, or in the population, are demographically nothing less than absolutely sensational. Sensational in the sense that they show marked changes in the basic structure of Texas society if we do not change the socioeconomic factors that are involved. The reality for Texas is that its future is tied to its non-Anglo populations, and how well they do is how well Texas will do. And I would argue, as I imagine everyone in this room would argue, that how well non-Anglo children do will be dependent upon how well we do in the educational system. Thank you.
Thank you so much, Steve. You came in within time, which is good because I had the time cards down here that they gave me to give the handout. So when we were planning this, we asked Steve to do a whole bunch of things, and when he presented his slides, there were 62 slides, and I said, Steve, can you think you can cover that in 18 minutes? He said, no problem. And so it was a data ride, and we certainly enjoyed it. Our next speaker is a man who's been in the Texas education scene from the beginning. In the 1980s, he worked for Ross Perot. Actually, Ross Perot paid his salary in the 1980s when Ross Perot led a commission that Bill Hobby and Governor White and Charles Miller and Charles Duncan wanted to put together about ways of reforming Texas. And if you remember the stories about they found a guy that showed a chicken for 20% of his school year, and then a lot of school districts shut down on the afternoon of the football game. And so they found a lot wrong with our systems, but they were able to get and make a difference. I learned last night that they used a screen called No Pass, No Play. It was a great upheaval. They're going to destroy education. That you would actually have to move from 60% passing to 70% passing in order to throw the football on a Friday night. And it was oh my God, it was going to ruin Texas schools forever. And from 60 to 70, but it was just a screen so they could do Head Start, lower class sizes, have school accountability, student testing, student achievement, and more equitable funding for Texas schools. They didn't get everything right, but they got a lot right, and we owe a lot to people like Darv Winnick, who is a UT research fellow. But most importantly for us here today, he is chair of the governing board of the nation's report card, the National Assessment of Educational Progress. We're so happy that you're here today. Darv Winnick.
You may need those cards, I don't know. Thank you and good morning. It's a little out of character for me to talk to a professional group. Historically, although I've tried to clean up my act some since I've been chairman of the governing board, but generally I was known as the designated irritant. I'll try to clean that up a little bit. But I said some time ago, and actually I'm not sure how many of you have ever been hissed at a meeting. It's an interesting experience. And actually, I used the phrase that I'm only going to talk about data, not dogma. And the audience went, and then it didn't get better. But anyway, going to try to talk some about data, as you, I hope, are an audience that likes data. Just a little bit of reform history, only because of the setting and the venue today. The Texas reform history, particularly in the elementary schools, has been well documented, talked about a lot. But the fascinating thing is that much of it started within almost shooting distance of where you sit. That the original meeting on what became the Texas Accountability System and other things was held at the University of Houston. The research that we used then, after a national search, somebody told me, why are you doing this? Just go down to the Health Science Center in your own town and get Jack Fletcher and Barbara Foreman, and they'll tell you what's going on. And out of that came the elementary reading program and some of the math changes that you know about. I only mention that, and I know Governor Hobby is not here today, but last evening we reminisced a little bit, and without him, we would have had a hard time starting. Several things, though, kind of set the stage, and I'll try to be brief. I'm not going to talk anymore about demographics. You've heard that, and Steve covers that very well. But I also must point out that during the time that we have been looking at changing schools, in a fairly recent history, we have had considerable change in the expectations for what I would call universal education in this country. Some of us are old enough to remember when grade school, maybe 7 or 8 grades, was adequate. That was considered universal education. That was essentially a 19th century, early 20th century model where you took care of everybody to get them so they could read the Bible. And beyond that, it was for the motivated, the able, and to some extent the affluent to go on. So we have a system that has had a hard time changing from a time when you only had to teach at the post-secondary level and to some extent at the high school level, the favored. So it was easy, relatively. That's changed. We now commonly talk about K-16, K-20. I don't know where it stops, but the expectation now that everybody will have a college degree opportunity is getting quite real. It's almost a given now that if you don't have a high school degree, you've failed. That's fairly recent. And that changes the demand considerably. There's also some changing characteristics, which I won't go into in detail. That's not my job today, but certainly it's already been alluded to. Family economic differences because of the demographics. Special needs students, I don't know whether it's, the medical people here might say, I don't know whether it's better identification or better diagnosis, but the numbers are up. And in many school systems now, by the 3rd or 4th grade, 1 out of 4 youngsters are classified as either special needs or English language learner. That's quite a demand. There's another thing that I didn't think to put on here, but it dawned on me last evening when I was listening. There's another changing characteristic which is dramatic and maybe one of the most important things to understand, and that is women's liberation. That has probably done more to change public education than any one social event. We don't talk about that very much. But the teachers that I had are now investment bankers. And they're attorneys. Some of it's your problem. You let them into med school. They're my dentists now. They would have, in earlier times, had the opportunity, if they didn't like blood and didn't like nursing, they would be school teachers. A very elite and a very highly proficient group that is not longer available for the most part. It's a dramatic change. Unfortunately, our schools are organized and in a large way operate, particularly at high school and post-secondary, just the way they did in the 19th century. So we're operating a school system for students that aren't there anymore, with teachers that aren't there anymore. It's kind of sobering. How are we doing? Well, the National Assessment Governing Board produces the nation's report card. This is a rather large data trove, and it's available to all of you. It's online, easily accessible. Go nationsreportcard.gov. You can actually do your own data research on it. You can play with different populations. I'm only going to pick just a little sample to give you some idea of what's there. We could take the rest of the day in talking about the data. Two ways that we look at data, and we do this because of an interesting thing. This is what Congress said we will do. And it's limited by what Congress says we won't do. What we will do is in two ways look at fourth grade and eighth grade performance in reading and math, science, I'm going to talk about today, and at other times in other history, civics, government, and so on. We're going to look at those in terms that are relative. In other words, we're going to look at scores of aggregated by students by state as it compares to another state, or in a rare case of some in a district as it compares to other districts. This is on an unanchored scale. It's just 300 here and 250 there. 300 is better than 250. Not sure better than what, but it's better than that. So that's relative, and I'm going to give you some relative results for Texas, which is what I've been asked to do. They are available also for Houston and Austin out of 11 urban school districts that we're trying to work, again, at Congress's request, into some comparisons so that we can get to a lower level. We are also asked by Congress, and I'll give you a little look at what I would call a more absolute, not a relative measure, but a more absolute measure. We call that achievement levels. In other words, at a certain content, quantity, quality, how many kids reach it. And we judge that because of history, long before my time, into what we call basic, below basic, basic, proficient, and advanced. It's kind of interesting. How do we do? How's Texas? Well, we've done some rather remarkable things in the elementary area. And I could go into details. We've to a large extent, we've reprogrammed elementary teaching in Texas. It's been fairly subtle. It's been over a period of time. And those who say that we led the nation in elementary accountability is probably accurate. We and a couple other states were very early on. And it pays. We have fifth from the bottom in economic wellness or economic value of our students. So we're fifth from the bottom in poor. We are, as you've already known, we're 35, 40, 50%, depending on where you go, Hispanic. In spite of that, not taking that into account at all, our white students score, in the relative sense, 10th in the nation, fourth grade reading. Our black students, 13th, Hispanic, 7th. Eighth grade, it's not true always that we're falling off at the fifth grade. We're falling off a little later. So the falling off is still a good, it's still a good concept. It's just we've pushed it out a little bit. Because in eighth grade reading, relatively, we're at 5th, 8th, and 12th. Not bad. If you take us just against the big industrial states, we lead in almost every category. How about math? Do you know this? Math teachers are shaking their head, yes. Well, you have every reason to. Third in the nation, third, first, I don't need to read the chart to you. When you disaggregate the data by racial ethnic groups, we do extremely well. Oftentimes the newspaper puts in the average, and we don't do quite as well as Vermont. But they're a little short on Hispanics and blacks. Not bad at all. All right, your interests. How do we do in science? Same kids, same samples, same time, same tests, the same testing time. Fourth grade, we're 25th in the nation. It's a rather startling difference given the earlier numbers. Eighth grade, aha, you want to fall off? 37th in the nation. We don't have good high school data by state. Congress and interest groups have decided they don't want to do that yet. But there's no indication from anything that I look at that says that we get better after this, which would be rather preposterous conceptually anyway. That's how we do relatively. Not bad. Certainly not bad, good. reading and math, the basics. And we put a lot of pressure on the basics, and we put a lot of pressure on testing. We put a lot of pressure in the, I've gone in my time at this when I was irritated because the only thing that got on the front page was football scores. Now I'm not sure we got what we wished for, because now you get displays of how your kids do and other kids do and the next kid maybe more than you'd like. But that's a change in terms of relative. But we're also been asked to judge absolute. How good are our kids doing against what they should do? How are they on standards that a group of knowledgeable people would say, this is really the science, or this is really the math that an 8th grader should know if they're going to go on and become a high school graduate and a college graduate? What is that amount? And it's not easy to come by. And we spend a huge amount of time, years, literally, on each set of achievement levels. The new math achievement levels, which are on the web if you want to look at them, took over 2 years. Over 500 people, public testimony, parents, scientists, professors, as I kid and said to my board, I want to leave no ideologue behind. If you've got an opinion about math and what is good math, come on. But I don't want to get those damn emails afterwards saying, you didn't ask me. So we've come up with these absolutes, if you want to call them that. And some debate, of course, but they're put together about as well as we know how. I've already said these things, so we'll go on. All right, how do we do absolutely? I've taken the worst case, because I did that deliberately. I have gone to the number of kids in our schools in Texas that did not get to the basic level. These are the number of students that we would say probably are going to have difficulty moving on. Now, motivation and things make that less than an absolute. But these are the youngsters that don't have what most people would judge are the basic requirements to get from the 4th grade and then succeed in the 5th grade, or the 8th grade to the 9th grade, and so on. 27% of our 8th graders score below basic in reading. So, relatively, we're pretty good, but not so good, maybe, in another way of looking at it. 37% of the 8th grade, I won't read the chart to you, but they're still below basic. 22% of the 8th graders score below basic in math. That's where we're doing well. 45% of the 8th graders score below basic in science. You say, with the exception of science, all those others are 2007 numbers. Those are numbers from the assessment was just done last spring. So these are most modern numbers we have. The science was done in 2005. Well, that's not so. Now, high school. What do we know? I have to shift now from the nation's report card, although we get some interesting national numbers in terms of what's going on in high schools. We don't have it disaggregated by state. From the numbers that Steve showed you, there's no good argument that we're doing better than the nation in high school. The data would suggest that we are doing less well. High school completion rates. Lots of controversy. How do you count them? Everybody's got another number. How many actually, what is the dropout number? Much of the data is self-reported. As the educators tell me, we put down what the kid says, and if he says he's going back to his native country, that's what we check. The fact that his native country is Sweden doesn't affect us any. So I don't know how to speak to that, but what I do know is that we have some good pipeline data. The coordinating board, the business community actually got the legislature a few years ago to put up a little money, and so we've linked some data sets, and we identify kids by social security number in Texas, and so we've got a fairly good idea of who actually gets through the system. We don't always know where they go within the system, but the numbers are not too different, I guess, than some of you are hearing now. But our completion rate, the number of 9th graders who get a high school diploma anywhere in the public system, in Texas runs 62, 63, 65%, and that's about it. So 2/3 survive, 1/3 don't survive, although they could have gone to another state. I mean, there's all kinds of things that they might have done. However, we don't talk about, there's also people coming from other states coming here, so whether it balances out differently. But we got about a 65% completion rate. I say you can argue it a little more, a little less. I might say, though, just because of this audience, our completion rate in post-secondary is about 1/3 that. So if you think the dropout problem is a real problem in high schools, it is. But we've done a fair job of getting kids into post-secondary education, and we don't do well in getting them out at all. Now, if you want to take a selective, wealthy, rich university that takes only a few kids from the top and graduate them, you should say, damn well they ought to. Just don't hurt them. Those kids do fine. They may not even need the teachers. But come on and look at the community colleges. Look at the, what did you say, 7 dwarfs? What somebody said? That's cute. But you look across the board, we don't do well. And we don't do well particularly in those kids that need remediation. You look at the throughput numbers, it's not exact, but you look at the throughput numbers and you try to find out where are the successes. Where did we take youngsters, students out of high school that couldn't read well and put them into developmental reading and whatever? We have funny names for that. We don't call it remediation. I forget, but there's a phrase we use. But you can't find those remediated students coming out with a degree or a certificate, or a welding ticket, for that matter. In minorities, the throughput for minority males from 8th grade through are in single digits. There are more minority kids still enrolled 6 years past high school than have received any kind of diploma. This is rather sobering. Different kind of things. I want to make one comment and then I'll stop. I've got one interesting slide. It's not a very good slide, but it makes a point that I think I had to grab this out of an old report and try to get it onto a screen. But what this shows is an interesting study of textbook difficulty. This is the reading demand for samples of textbooks. And at the bottom, little bar, that's the results of a junior and senior high school set of texts. It's put on a scale. It's hard to read, but at about 1,100 of these particular scale values is where high school textbooks are. That's not where kids read. Some read much better than that. Some read not that well. But that's the textbook demand. All right, go on up that chart. Hard to see, but if you go up several, you'll see military. That's the average reading demand of military manuals. Most high school kids are going to have trouble reading a military manual. Go up workplace demands. And then you get to third from the top, that's community college. Those are the textbooks that we use in the first 2 years of community college. And this is generally in the general courses. This is general biology. This is general history. These are not, I'm not selecting out advanced courses. Well, I just make the point that it may be, one of the things we may not talk about adequately is the rigor of our courses. It's interesting in the national data, and I will end with this, one of the most sobering things to me in the last year has been a look at the so-called transcript studies on the nation. We don't have them by state, but these are transcript studies on what are the youngsters, what are the students taking. And to your credit, and you're talking about it here, and you're proud of it here, the number of students who take advanced placement, steady rise. International Baccalaureate, steady rise. The number of, a big jump in the number of students who report second-year algebra. Start with a fairly small number, but calculus is up. The number of students now in high school in America that take biology, chemistry, and physics. We learned last night, maybe out of sequence, but the number who take it, all those are up. Very satisfying. Except the high school math scores and the high school science scores at best are level, and in some cases are going down. Now, if there's anything more sobering to you all, I don't know what it might be. We may call it advanced algebra. We may call it AP. But what do we teach? What is the rigor? Well, so be it. That kind of tells you fairly good news elementary, mixed reviews middle, questionable high school, and post-secondary, frankly, every way we can look at it, pretty poor outcomes. And most of you here and me have never been in those universities where we're not getting it. Most of us, unfortunately, I'm one of you, look at education somewhat from the view of graduate school, selective. That's not representative of the population, obviously. I think, and this is the designated irritant pitch coming out, I don't think education can reform itself, nor can industry, nor can anybody else. The history of corporate America is when you get in enough trouble, you go out and get a CEO from somebody else. IBM got turned around by a grocery producer or whatever. You've got many of that, and I think that's the same issue. It's very hard for any of us to reform ourselves. The vested interests are just too great. So you need to intervene. You've got to get other people to intervene. I think history will say we've done well in education in the elementary grades because we intervened. We messed up. We messed in. And some of the teachers were very unhappy. We said there's certain things you shouldn't do. We turned around and managed. Well, anyway, we did a number of things. We probably need to do that in high school and college. And one of the things you have to understand, the interest groups in college are much more powerful than in public ed because they have football tickets. It's not to be ignored. You want to take a good spin? I'll give you a good spin. You want to run for office? I'll give you the spin. The spin is that we're still clearing the pipeline. The good kids are not there yet. That's the best hope. These good math score 8th graders, and it's true, some of these things are fairly new. So that's the good spin. We're just not there. Wait, and the good kids will show. The not so good spin is maybe more realistic, or maybe somewhere in between, I don't know, but we probably need, and this is why you're here, and this is why I took time out of a vacation trip to come here today to tell you right on. You got a lot of work. Don't fall into the trap that we know the answers, just send us the money. Don't fall into the trap that we know what's necessary, we just don't know how to do it. All my look at elementary education when I got there, we didn't know. We felt well. I mean, we tried. It wasn't a matter of motivation or attitude or honesty. We just didn't know how to educate the kids that are there now. We're still educating the 19th century kids. The second thing, and I'll end with this, is trite and true, and that is that things that haven't worked in the past generally don't work in the future. Thank you.
Thank you, Darv. Certainly set the context for where we are in the answers in the students, because they can provide the data that we need to move forward. Tim Scott's coming forward. Tim, we're going to rush you through your presentation, but you take as much time as you need, because these people will need to get a cup of coffee here, in the next 15 minutes. But we want to hear certainly what you say. Tim Scott is a biologist and chemist. He is an undergraduate dean at Texas A&M University. Without question, no one in the room knows as much about crocodile and alligator behavior than Tim Scott. I'm feeling pretty comfortable saying that with this group here, but also probably Tim knows as much of what's happening in our Texas classrooms as anyone in this room. Tim?
Good morning. when I worked with TEA on certain contracts, they said, how does somebody who works with alligators find themselves working in education policy? And I said, it's easy. You just got to know which end to grab. So I'm always trying to impress my wife. I haven't done it yet. I just had a horrible conclusion last night in talking to people around the table. My wife is an educator. She has a passion for working with at-risk children. She's a principal now. In fact, my wife is my boss's wife's boss, and we went to the Aggie governor, it sounds like governor, we went to the Aggie lawyers, and we said, we're concerned about a triangulation, and they plotted it down and showed us the graph, and it's a square, and they said, don't worry about it. But I told my wife after the dinner last night, I said, is this impressive or what? And she said, the meal was delicious, the speakers were right on. And she said, but if you guys don't do something for teachers in public schools in Texas, I'm going to be really mad. So people ask me where I get my passion. It's there because if it's not there, the nights are rather cold. And my physics friends try to figure out the thermodynamics. It really has more to do with life science. As we address the rising above the gathering storm in Texas, I feel a little bit like a meteorologist standing before you as I give you the current weather conditions and the probable forecast. As Darv mentioned, I'm going to give you a snapshot. Because the passing standards in the state change each year, it's hard to follow longitudinal trends. So I'm going to give you the most recent disaggregated data made available to the public. I don't want you to rush to judgment. There is no need for knee-jerk reflex reaction. We didn't get here overnight. We're not going to dig our way out overnight. It's going to take concerted effort. They keep talking about Sputnik. I have an interesting statistic for you with Sputnik. Is the year before Sputnik was launched from Russia, we produced twice as many physics majors as we do today. And we considered it then a national crisis. I'm going to frame my comments in the National Science Board recommendations. First of all, if you parse down that document, they say we must strive for coherence in our curriculum and solid vertical alignment. And then you cannot underestimate teacher recruitment, teacher preparation, and retention of teachers. In truth, we don't have a shortage of certified teachers. We have a shortage of certified teachers that stay in the classroom. What can we do to reverse that trend? So like Steve, I'm going to show you some slides, and I have taken the liberty to highlight those cells that I want you to look at. I give you 14 years of data from 1991-92 school year to 2005-2006, and you'll see that Texas school populations grew by over 1 million students. If you look at the Hispanic population at 800 and almost 50,000, you see that that subpopulation accounts for 81% of the growth. The second fastest growing population is one we don't like to talk about, but it is our economically disadvantaged. We weren't measuring it in 91-92. We began measuring it in 92-93. So for 13 years, it accounts for about 40% of that million student increase. Then if we'll contrast that with our teachers, who is in front of this very diverse set of students in Texas, you see now a drastic reduction in the diversity. We're most diverse probably in life sciences, in biology. And so if you see that Hispanics, there are about 14% Hispanics in public classrooms, most of those would be biologists. And if you look at 8%, we're talking probably about physical sciences, chemistry, and physics. One thing I want my colleagues in colleges of science to note is just as we wring our hands and worry about the next generation of physicians, dentists, engineers, and scientists and the representation from our population, it is equally as distressing when we think about those folks who are in front of our classrooms. We've got to strive to open up that pipeline, provide incentives and encouragement along the way. Well, let's talk about how we do with some tests. Texas has been fairly aggressive at high school graduation requirements. We just ramped up to 4 years of science, and we applaud that action. Previously, it was 3. When we took a snapshot in 2004 and we said, well, how many Texans take biology? We look like the nation, over 95%. And how many take chemistry? And we have 79% compared to 60%. And in physics, we even do better, though we're far from where we should be. But earth science is a huge, gaping hole. And my friends in geology, geoscience, are very concerned, and in part, it's due to the lack of alignment and coherence of the earth science curriculum. When we look at the ethnic breakdown, again, these aggressive graduation requirements serve us well. We're faring better in every category when we look at the nation. Now, this is a busy slide, and I apologize, so let me walk you through it if I can. On the far left-hand column, you'll see the passing standard. This is what can change each year after it goes for panel review. So in other words, this is the 5th grade tax test. It's given in Spanish here. The pass rate was 78%. The 5th grade English was 75%. Ordinarily, these are together. There must have been a question that was thrown out here. The 8th grade is 54%. In other words, if the student gets 54% of the questions correct, they pass the tax. The 10th grade is 62%. And finally, that all-important exit tax test. In order to make sure you graduate, you must get only 52% of the items correct. As distressing as that is, as you look at, and this is the summation of all students tested, it is pretty much like gravity, it just falls. 75% pass the English version at 5th grade when the standard is 75%, 71 pass at 54%, 60 pass at 62%, but lo and behold, when we drop it to 52%, we can get 92% of the students through the pipeline, okay? I want you to note that and follow that trend through. In the second slide, I want to tell you about our English language learners. Houston, we have a problem. We're going to see this gap, and it becomes even more worrisome when we talk about math when we test consistently from the 3rd to the 11th grade. Now, when you think about our population, 81% of the growth in Texas schools has been Hispanic in the last 14 years. We have to solve this problem. I gave this presentation a little bit, a sneak peek to our Development Council, and they got into an argument about bilingual education. And that's why I said, you can't knee-jerk reaction to this. The whole nation's looking at this. California's grappling with this. We've got to figure it out. Let's look at other ethnic groups, African Americans, Hispanics, economically disadvantaged. What you want to see is that if we look at the 5th grade English test, 75% of the people pass, Caucasians 88% pass, African Americans 59%, and the difference between Caucasians and Africans is 29 percentage points. That's what the parentheses is for. It's 21 for Hispanics, and it is 23 for economically disadvantaged. And as we go up, so do the gaps. The only time we change the trend is at 11th grade. When we drop it to 52%, we can narrow those gaps. Okay? The other thing that I want to share with you is an observation. I'm not sure what the stance is in America on the war on poverty. But I am as much concerned about educating economically disadvantaged students as I am different ethnic and cultural groups. And I'm not so sure that what we really have is more of educating the economically disadvantaged and those that aren't disadvantaged. And I think the data is beginning to bear that out. How do we reach poor children and bring them up to speed to break that cycle of poverty in their lives? If we are waging that war, I am not sure we are winning it in the classroom. What I've done here is I have taken the objectives as lined out by Texas Education Agency, and I think we have two of the finest people in science education in the country, Chris Comer and Irene Picard. We couldn't ask for better. The best thing that we can do is get out of their way and let them do their work. So if you see the governor, tell him I said that. The objectives here, 5th, 8th, 10th, and 11th, nature of science, life science, physical science, and earth science. What you get is the percent mastery here. What you get in parentheses is the number of questions they are tested over. What you see is good alignment. What's the alarming part here? Look at the blank over here. Where's earth science in high school? Not there. Not tested. It counts as an elective credit. And even the 4 years of science, I am not sure, is going to address this problem the way that it's currently structured. Very disconcerting. This is even more alarming. Science objectives, what I have done is I have shaded in where the mastery is less than 70% by objective and grade level. So at 8th grade, you'll note that nothing is mastered as high as 70%. Nothing. And at the 10th grade level, 4 out of 5 come in less than 70%. And at the 11th grade level, even at 52% passing standard, 4 out of 5 are still less than 70% mastered. When we look at AP scores, we trail, though slightly, in every category. When we look at demographics, we may see reason for hope. We'll say, well, 5% of African Americans in Texas are taking AP exams compared to 4% in the nation. Well, let me recall the first demographic slide. 15% of our population is African American. We're not yet representative. And what's the percent of Hispanics? Over 45%. And we've got 17% taking. We are still a ways off in getting adequate representation in advanced placement and IB curriculum. When we look at ACT, mean science averages, it's a little better. African Americans in Texas actually fare better than the national average, and Caucasians tie it. Here is a controversial topic, and my dean keeps saying, where did you get this slide? I am not sure it's correct. What we're doing here is measuring out-of-field teachers. Now, out-of-field is very hard to define. I'm going to do that for you. Just let me tell you this. On a national average, according to the Rising Above the Gathering Storm document, 45% of the teachers in the nation are teaching out of field. You look at that, you say, well, we're not doing bad, we're approaching it. Guess where? Earth science and IPC. In 8th grade math, it's worse. 59% of students are being taught by out-of-field teachers. What's the international average? 30%, much lower. To teach out of field does not mean these folks are degreed necessarily in these areas. So when we look at physics teachers, I think if we looked at the persons who have a degree in physics, it would be much, much lower. They simply have enough coursework to sit for the exit test and pass it. Okay? So we're not talking about degreed in the area, we're talking about passing an exam. Well, math. I'm going to talk about math for a little while, and it's going to take me more slides to show math. I'll rush through them because math is tested consistently from the 3rd to the 11th grade. Science, we get 4 shots at it. Okay? Now, again, you'll notice the trend, except in elementary math, the passing standard stays consistent between 67 and 68%, and roughly 83% of our Texas students are meeting that standard. I like the consistency. English language learners, there's the problem. They still trail 14 percentage points in both the 3rd and the 4th grade, and in the 5th grade, they trail by 33 percentage points. It more than doubles. The longer that English language learners, or the older that they become taking a test in Spanish, the farther they fall behind. The intervention must be early. What about ethnic groups? African Americans range between 18 and 21 percentage points behind, Hispanics between 12 and 14%, and economically disadvantaged between 14 and 16%. Again, I believe if you look at the economically disadvantaged washing over those groups, we're talking about a war on poverty here. Passing standards in the 6th grade. Remember, they were at 67 to 68% in elementary. They dropped 63, 58, and 60 throughout middle school. Those meeting the standards dropped from 81 to 71 to 68. We're seeing that free fall, that phenomenon that happens in middle school and high school that gets worse. When we look at the final test at which they can take in the 6th grade year, we end with 27 percentage points behind folks taking it in English. Ethnic groups continue to widen the gap. African Americans grow to almost 30 percentage points. Hispanics go to the low 20s from the teens, and the economically disadvantaged also climbs to almost the mid-20s from the teens. And finally, when we get to high school, again, notice what has happened. Remember, in elementary, 67, 68 drops to 60% in middle school, and from high school, 9th goes 60%. You pass the questions, you pass, 59% in 10th, and 55% in that all-important exit test. When we do that, we can get 78% of the kids through, even though the prior 2 years it was 58 and 62%. The gaps continue to be very high, 35, 33, 25 for African Americans, high 20s to the teens for Hispanics, and 30s to 20 for economically disadvantaged. Let's look at the standards now as we did in math. Elementary looks good. I like mathematicians. They're so nice and linear. They've got it in table. It all lines up, goes, life scientists want to split the cells and whatnot. Remember, this was a 67, 68% passing standard, and 83% of the kiddos are meeting it, and you see that reflected in the mastery of the objectives. In middle school, we begin to see that troubling trend. By 7th grade, 3 of the 6 standards are passed at less than or are not being passed at 70%, and in 8th grade, it grows to 4 out of 6 objectives not being mastered at 70%. And then high school. Here comes the blue again. And what I've taken the liberty to do is to shade in the objective where we never see mastery at 70%. Linear functions, geometry and spatial reasoning, measurement and similarities. My statistics dean, percent, proportions, probability and statistics, and math process tools. In 9th grade, we have no mastery at 70%. Troubling. Well, let's go back. I started out by framing it with National Science Board recommendations, and I'll close with that. Coherence, what does it mean? It means that we'll put down silly turf battles. We won't take up math wars or begin science wars. Agencies like National Science Foundation, Department of Energy, National Institutes of Health, and the Department of Education will attack this problem together and consolidate efforts, not divide. It also means the same should occur in our state, the Texas Education Agency, the Texas Higher Education Coordinating Board. Our standards are very good in Texas. I'm proud of those. I served on some of the review panels, and I'll serve on the revisions again. We may have to rethink the standards, and what we keep hearing is we've got to go for less, mile wide, inch deep, and more deep, rich content knowledge. The problem is when you get people around the table, what gives? But when you think about how science is done, it is a process. You don't ask me many physics questions because I'm going to find you Michael Martyr. Okay? The coherence and the vertical alignment must span to college. A&M's got to buy in, UT's got to buy in, all the 7 dwarfs have to buy in. And we've got to reach out to community colleges. You want diversity, you go to community colleges. If they can't make the transition, we've got to build a better system. The coherence must address English language learners and the economically disadvantaged. And finally, this will be somewhat controversial, but oh well, I'm almost through. Assessment is an extremely useful tool. We use it in science all the time. We look at the data. We try to interpret what it means. We'll spend effort and energy specifically where the data is lacking. And I think assessment is extremely useful. It has helped us reach out to all subpopulations, which we weren't doing before, measure progress. But also in our schools, it has become an object of fear and repercussion and funding. And the schools, many times, most affected are those that need the resources the most. We've got to do a better job in assessment and balancing it. It is good. I don't want to go back to the days where we don't have it, but we have to strive for more balance. We think teachers are leaving at an alarming rate. The pressure that they are under is enormous. In terms of teacher recruitment, we have to have more models like you teach at Austin and math at Texas A&M University. How can the legislature help us? Well, they could increase formula funding, and it wouldn't be two flagships modeling this, but it would be everyone in the state. Scholarships for our students. NSF has a Robert Noyce Scholarship Program. You get a scholarship, it's good for up to $10,000, and guess what? You don't have to pay it back if you'll teach in a high-need school for 2 years. We need that for more disciplines across the field of STEM, science, technology, engineering, and math. Lastly, we have to address the age-old problem of salary inequities among educators. We have to look at differential pay. We have to look at merit pay. What other organizations do we belong to where the worst in the profession and the best in the profession will make exactly the same thing simply because they've endured the years at the school? Where is the incentive? Where is the reward? Do we blame them when they leave? It's interesting because, speaking on that subject, I found this article, actually interviewing a former teacher. And she said, well, you know, my great-aunt talked about this in 1946. This is this famous scientific journal called the Ladies' Home Journal. Over here's July 1946. And the headlines, which you'll have a hard time reading, says, "Who will teach your child? A whole generation of school children is going to be hurt by the coming teacher shortage. The reason, poor pay." We have been discussing this problem for over 60 years. It's time that we roll up our sleeves and take the steps to correct that. We have done everything in the world except that. Let's try that for a change. What will the price tag be for to enact the recommendations of the National Science Board? Initially, they are $9 billion. At steady state for the country, it's close to $20 billion. And so some people that are pragmatists will say, well, my Lord, can we afford that? But I think the real question is, can America not afford to not to do it? Thank you very much.